Alright, so now I'm going to show you a construction for an approximation of E, which is much better than the one that I noted the other day. It is basically 2 square roots of 2 minus the fractional part of the square root of 2 times our established approximation of the fundamental circle constant, which is 1/4 of pi. And this comes out to be, if you do everything absolutely perfectly, 2.7179. And E is 2.71828. So quite close right here. And actually, if you use the fundamental circle constant itself, you don't get as good an approximation. So the fact that our approximation for the fundamental circle constant is actually off and in the correct direction improves this the accuracy of this construction. So if we use the fundamental circle constant directly, this would be our precision. It comes up slightly, very slightly. So recall if we do the fundamental circle constant construction with a sheet of paper, the error is within the width of the crease. Here, the error is about twice as big, but it's still very likely to be within the width of the crease. So this is still effectively about as good as you can do. We do have the problem that we're going to be working at half scale. So the error is actually twice as bad as this. So it's not as nice as our approximation of the fundamental circle constant, but it is still pretty accurate. Anyway, alright, so here we have laid out our construction for the fundamental circle constant, which is right here. So 0.785 lies right about there. That's 1. And because this doesn't extend far enough to get E would be over here, I think. Over, let's see, 6, 7, it would be over here. Just off the page. We could drop it onto the diagonal at the correct scale, but that's kind of awkward. This is going to be really elegant. We're just going to drop in a few lines and we'll get 1/2 of it. So here we're going to drop in our target line right there. Alright, so what we're going to do first, we're going to note that we already have our fundamental circle constant times square root of 2. It's this distance right here. So we're just going to fold this down to our line here and mark it off. And we already have the crease that'll bring it down. It's this crease right here. Alright, so we're going to bring this point down here and we're going to mark it with a vertical crease. Okay, now, because we're cutting everything in half, we want 1/2 of the distance between 1 and this crease. So we just bring this crease to this crease, and then we get that mark. And that is now our reference mark. And now we want to bring this crease, 1, to this point. This is square root of 2. This is where this point comes down. So that folds us in half like this. And then what we want to do is we want to mark where this line is over here. And it's going to be, boom, right on top of 1/2 of E. And if we zoom in, see how accurate this is. It's pretty good. It's pretty good. You have to zoom in quite a ways for it to really be noticeably off. It's not as good as our approximation of the fundamental circle constant, but it's pretty good. It's pretty accurate. And that's all it is. It's just 4 folds. First this one, marking where this point hits this line right there. And then we're cutting this distance in half. And then we're bringing 1 over to square root of 2. Square Square root of 2 being where this point hits when we fold along this, which we already have established from our construction. And then we just find where this hits this. And that, if we scale this down, instead of having this be 1/2 and this being 1, we have this be 1 and this be 2. And there you go. You have a very accurate construction of E, built upon our construction of the fundamental circle constant. Neither of them are perfect, so they're still unconstructable values, but these are such good approximations that if you need these numbers for anything, you can absolutely use them, right? And if you want to treat this as pi instead of pi on 4, just treat this as 4 and this as 2. If you want it to be tau instead of pi, treat this as 8. Right, that's how easy this is. If you want it to be pi on 2, treat this as 1 and this as 2. That's how easy that is. Okay. And if you want this to be, if you want these to be commensurate, if this is 1 and this is 2 and this is E, this will be pi on 2. So there you go.